Today's topic for the fall workshop training series by Pentek is Pentek drop-in filter cartridges, centered on carbon filters all alone. We're going to do the next Tuesday sediment filtration, but we're going to do carbon filtration this week, and then 2 weeks from now will be our specialty cartridges. So this week it's going to be carbon filters, theories and practices behind it. So that requires us to start off discussing a little bit of the ingredients that go into a cartridge. Carbon filtration is a very, very old technology, even before we really understood what it does. Ancient Egyptians, Indians, and Persians placed charred wood into their beverages to improve the flavor. Little did they know that they were removing contaminants by doing so. And this wasn't truly activated carbon, it was just charcoal. So only part of it was activated. So it's an incredibly old and versatile technology. It's amazing how many modern things we think of are really old technologies we've refined over the years. So there are lots of different types of carbon on the market, and the raw material that we form carbon from determines the properties of which it's going to have from a filtration perspective. Coal-based carbon tends to have larger pore sizes. This is better for color and musty odors for large molecules, organic molecules in the water, and is less expensive. Coal's a rather large commodity out there in the marketplace. Coconut-based carbons, this has a tighter pore structure, much smaller, and this is better for VOC and trihalomethanes removal, smaller organics. And then there's a mix of those are quite often done in certain applications where you want to cover a broad spectrum as well. And then there are specialty carbons. And most of these, it's really difficult to wrangle this sort of information from the carbon manufacturers, because they're doing organic chemistry here where they're putting specialized functional groups onto the carbon itself to act as catalytic sites or exchange sites for doing more than adsorption. They're doing catalytic reduction. That's what's happening with chlorine and chloramine on the carbon. So we'll get into that in a minute. There are lots of different ways that activated carbon does remove compounds, but these are just a small list of the different compounds they're designed to remove. They convert chlorine into chloride. You're able to remove colors, tannins, chloramines, pesticides, herbicides, industrial pollutants. Some of these even have lead reduction capabilities, MTBE, VOCs, and trihalomethanes. So basically organic compounds that tend to be less polar, more like oils and greases, and small things that are charged are removed by activated carbon. So we want to choose the right tool for the right job in our filter applications or drop-in cartridges. So basically this is a raw material generated from natural products, whether that's coal, which is just organic material layered, lignite coal, coconut carbon husks, bamboo, sawdust, wood, you name it. If it's an organic cellulose material that we can combust and turn into charcoal, we can turn it into activated carbon. But the source material itself will dictate what sort of contaminants it has in it due to it being a natural product. Wood, sawdust from various other plants, hemp is another one coming out these days for the cellulose fibers involved, bamboo, coconut husks, all have varying different degrees of heavy metal contents based on the soils they're grown in. Okay, these materials will have contaminants based on what they grew in and into the material. That's why coconut carbon is so highly prized, is because we are getting this material from parts of the world where there is less air and soil pollution, so you get a purer carbon. Whereas with coal, long-term in the ground, been in contact with all sorts of geology for a very, very long time, was able to pick up a lot of different metals. So The processes in which these are refined determine the overall product in the end. And what makes activated carbon such a versatile product is 2.5 grams, about the weight of a penny, is equal to the size of a football field in surface area. And that contact surface area is what is critical in removal of contaminants from whatever process, whether in our case, it's mostly water, but whatever process, whatever we're trying to use activated carbon for to purify something, it's this massive surface area in a very small package that gives us the capability to refine things rather quickly. So how does activated carbon work? Well, the chemical removal, and this is, we're talking about the organics, not chlorine and chloramine here. It works on the principle of adsorption. This is like attracts like in chemistry. Okay, this is polar versus and non-polar making contact. That surface of that carbon is non-polar for the most part, except for certain catalytic sites where metals were pulled out and things were added. That surface of the granule that is mostly carbon will attract oils and greases to it. This is the same thing that happens with oil and water separating, or oil and vinegar separating. That vinegar is an acid, it's charged, the oils separate. Even if you have a partially charged oil, it's still going to separate. There's a spot where they mix in between. There's a thin layer there, but the majority of stuff is pushed up against, into a separation layer. That's what's happening with activated carbon. We're giving a layer for those organics to plate out on or coat out on in mid-water stream to remove them from the scenario. And they stay adsorbed to the surface of the carbon. So adsorption, typically good at removing other carbon compounds via adsorption. The more insoluble the contaminant, the easier it is to remove. The less charged an organic compound is, the easier it is to remove. But that's not true of all organics. Most organics will have a partially charged, especially the stuff that we consume, medicines, things like that, typically have a charge. So activated carbon will remove a lot of that, not all of it. And you can see contaminants are stuck in pore sizes based on those contaminant size. So big pores typically are made of wood. These are macroporous carbons, large openings for large organics, fats, oils, and greases. Mesopores are medium. This is typical in coal. This is because of the compressive force of their formations. And micropores, typical of coconut, and that's just due to the cellular nature of that particular cellulose fiber as it's grown. So we match the pore size to contaminant size. We give you a blend of these for a general catch-all sort of material. So if you're going to see different blends of these, or why coconut carbon is being used someplace and not another, it's because we're targeting a specific contaminant. It doesn't mean that coconut carbon will not remove some of the big contaminants. It will. It's just better at removing the little ones. So different size contaminants are attracted to different pore sizes. Small molecules that are attracted to the micropores are trihalomethanes, methane, ethane, other small organics, small oils, larger molecules. This is your petrochemicals, your pharmaceuticals will fall into this category. Even though the product may not be certified to remove pharmaceuticals, activated carbon of the right sort will still do the job. So how is chlorine removed as hypochlorous acid as a sanitizer? Both chlorine and chloramine are removed via a catalytic process where we're breaking in chlorine, we're converting hypochlorous acid here to a carbon, which is your carbon in your filter, with an oxygen added with another catalytic site, plus acid and chloride, and this acid will go back and forth on this oxygen molecule here to make this actually an alcohol, and that can break out and form water again and reactivate the site. That's why you get some regeneration of catalytic sites in activated carbon while it rests. What's going on with chloramine is you're cleaving that chlorine ammonia bond, and you are converting that to chloride, but the ammonia will then be bound to the carbon much more strongly than this oxygen. So you're actually removing there. But in the case of chlorine, we're converting it to chloride so it doesn't taste or doesn't have a smell to it anymore. Now, performance factors when we're talking about carbon filters. Filtration efficiency and micron rating. Filter efficiency is how much dirt load a filter can handle, and the micron rating is the pore size of that filter on what it's going to remove. Dirt holding capacity is per gram of weight of debris versus size of the filter. Very, very critical when understanding choosing a filter for an application, because we're dealing with real world applications here that have dirt in them. A carbon filter just rated for chemical extraction, like most of our competitors are, don't function well in real world environments because they're dealing with dirt. Pentek filters are rated based on real world water qualities and average tap water quality at tested NSF, not laboratory water free of debris. We want to understand how they perform in real world applications. Pressure drop across a filter as it loads. This is critical. Pressure is the driving force of all filtration. We don't have good pressure, we're going to see a greater pressure drop across that filter over time as it loads dirt. Media migration and particle retention. One of the things we don't think about in filtration is that as water pulses through, you get a relaxation and a force placed back on it. On that filter cartridge. So you get the already retained dirt in a filter puffing and sort of breathing a little bit and reorganizing inside a filter. And how often that does it and how much you're able to reorganize that dirt in a way that allows for greater flow will impact the life of the filter. It's a lot more complex than throwing carbon in a can, behind this. And then there's chemical compatibility. If we're going to do more than just water, or the water itself may be in a state where pH is excessively low or excessively high, things like that. Is that what we're trying to filter compatible with the carbon and the housing we're putting it, the materials it's constructed on? We got to make sure we dot that I and cross that T. Now, cellulose-based filters, this is paper-based products, should be used on chlorinated supplies. Why? Because non-chlorinated supplies and cellulose fibers means there's going to be bacteria in that supply at some point in time, and bacteria will attack and break down cellulose materials. So use the appropriate material where it's needed. Synthetic fiber filters that have carbon in them can be used on chlorinated and non-chlorinated supplies. Tend to be a safer choice when it comes to selecting a carbon filter. Now, dirt holding capacity is the measure of the weight gain of a filter during its useful life as pressure drops. over a 20 psi pressure change in the filter, how much dirt can it hold? So most of us aren't getting into that, that concept, but that explains where our filter short lives come from, is our dirt holding capacity. Because activated carbon filters do mechanical filtration and chemical. So the operation of any filter depends on differential pressure. If we have low driving force, low pressure to start with, we're going to have a shorter life of that filter, period. We don't have the force to overcome dirt load. But we also don't want to have too high a pressure that we're damaging the filter as well. So we want to make sure we have hard cut supply. So if you're having somebody who's having short filter life, what's their pressure in that building? Maybe time to install a water boost or increase the, if they have a variable, drive well pump, increase the pressure coming out of that well pump. So those sorts of things can have profound impact on a filter. Or put a little pump in with a reed switch. As flow begins to go, it triggers a pump to kick on, increasing pressure through that filter. Location. Do we have the space to put that filter in? All right. That gets overlooked a lot. Dirt holding capacity, once again, will this filter survive long enough in the environment it's in to give us the value it has. So, a 200,000 gallon rated carbon filter does me no good if it only lasts 3 weeks because of the dirt load of my water. So, pressure, once again, we're looking under 125 PSI, and no vacuum being placed on these housings when it comes to Pentek housings. Filter's efficiency is a percentage of the particles, specific size in microns that will be removed. And this is important to understand. All the Pentek filters sold through general distribution are nominally rated filters. A nominal rated micron rating means that it will reduce that particle size. So if it's 10 micron, it's going to remove that at an 85% efficient rating. Now, if you want to understand what the filter really does, go to the NSF website for ratings, because all of our filters outperform this 85% nominal micron rating. This is the bare definition of what nominal means in filtration. We exceed that, typically approaching 90 to 95% over the standard nominal. Now, absolute micron rating, this is reserved for medical devices typically. And this is where we're removing 99.99% removal. And the reason this is there is because of bypass at the top and bottom of filter through pressure or water hammer in a system causing blow by instantaneously. So that's the reason why this isn't 100% on an absolute micron rated filter, is you do have those minor technical issues there to resolve. So understand that we are selling nominal rated. If you need an absolute rated filter, please let us know that and we can hook you up with our medical group that does that sort of filtration. So the other thing is, what's in my water do I want to remove as we go to select these carbon filters? Sediment, anything from sand, silt, rust, scale, particulates, all this stuff has different characteristics. It's going to load a filter differently. You're going to want to pick what's best for your environment, especially silt. That's really soft and mushy stuff. It's going to load up a filter and plug it. Taste and odor. What's giving you your taste and odor? Is it chlorine? Is it tannins? Is it hydrogen sulfide? Understanding what's causing that allow you to select the right filter. Chlorine, chloramine allows you to pick the right carbon. Chlorine carbon will not remove as much chloramine as chlorine, 1/10 of the amount. Chloramine carbon needs to be specially activated to break down the chlorine ammonia bond and then bond the ammonia. So very, very different, much more expensive carbon is used in chloramine carbon. And then cyst rated. This is for bacteria rated down to 0.5 micron for removal of or microbiological critters, not viruses though. Then there's hydrogen sulfide. This is rotten egg smell in your water. This can be removed by activated carbon. You just need to understand how much of this you have and how much that activated carbon filter will hold. VOCs. This is volatile organic carbons. This is stuff you can smell rather easily when you open a jar or spray something. This is herbicides, pesticides, industrial solvents, PVC solvent, that type of stuff. May enter the water supply through agriculture or industrial runoff or a byproduct of chlorination. VOCs are suspect to cause certain health problems. I don't want to drink them either. This is where a good coconut carbon, if you have this in your water supply, may be a good bet or a mixed bed. Lead. Certain filters are rated for lead removal, may have additional additives to do so as well. So we need to know what problem we're solving to select the right filter. Now, when it comes to understanding micron ratings, a micron is 1/1,000,000th of a meter. That's darn small. A human hair is up to 80 microns wide. A razor blade is up to 400 microns thick. 25 microns is 1,000th of an inch. Okay. Fine test dust is 0.5 micron. Pseudomonas dementura is 0.3 microns. So we really need to get down to this 0.5 micron to start dealing with biological things in the water. So what kind of filter are we using? We have activated carbon filter, but are we going to apply that to a surface filter or a depth filter? Surface filters, all the particulate loads on a skin, essentially a fabric or a screen, and once the holes in that screen plug up, it's done. They tend to be lower dirt holding cartridges. So if we're going to use a surface filter with activated carbon, maybe doing it on relatively pure water or as a polishing filter to an RO system. Good place for a surface carbon filter. Depth filters have the ability to hold dirt and debris in a tortured path through a material, a matte sort of material, whether that's string wound or a poly mat or a Fiberdyne wet molded block. We have depth the whole media, debris in that media. This gives it longer life, stronger, more strength of that cartridge, and the ability to reload as the water pulses through it. In theory, surface filters will work better when particle matter in the water is all the same size. Depth filters work better in a broad range of particle densities. Performance factors. Remember, understanding your micron rating, your filtration efficiency, and how much dirt you're dealing with. Okay. So chemical compatibility, activated carbon filters are not just used on water. There's opportunities out there, lots of different markets. So if you are filtering other fluids than water, always make sure that all the components of the filter and housing are compatible with the fluid being filtered. Think of pulp-free orange juice. Something's removing that pulp. Is it just being strained or is it being run through an activated carbon filter? Is that material compatible with the product? Okay. Be aware that most cellulose-based filters have residual formaldehyde that will elute into the filtered fluid. So if you're going to use a cellulose product, use it in front of an activated carbon product for filtration when it comes to sediment. But if you have a paper product, realize you may have some break-in period to get rid of this chemical off the paper. So it's a byproduct of paper manufacturing. So where do I treat my problem? Do I want to do it as point of entry? Is the issue large enough that I want to treat it where it comes into my home? Or do I want to treat it where I use that water? Now, in some places, you may need to do both. If you're in North America and you live in a community that was built before 1986, when there was still, or actually before 1965, there's lead service plumbing in the ground. In Chicago, Illinois, that's 1986. So you're going to need point of entry to prevent lead particulate coming into the home. But if that same house was built before 1986, it could have lead solder. That's a situation to manage a lead issue. I'm going to need point of entry and point of use treatment to manage lead exposure. Whereas point of entry, I could have a carbon filter, big blue housing at the entry point of my home with a lead removal powder and manage the lead coming in from the municipal supply if my home was built after 1986. I have no lead solder in the house. I don't need to protect myself from lead there. So understand the issue you're dealing with, and you'll be able to filter. Plus, only 2% of the water in the home is used for drinking and cooking, which means you can save people money not wishing to over-treat other issues. But that's all perspective at this point in time. So how sediment filtration works in any filter, you're going to have basically a pore size. You're going to have that particle directly hit the material, or you're going to get multiple particles plugging up the pore size and capturing debris. Okay, that's how particles get trapped, either direct interception or bridging. That way. Now, when it comes to drop-in filtration, you can have parallel flows design. So if you need to get higher flows out of a specific type of cartridge to manage an issue, thinking hydrogen sulfide possibly in a resonance, you could plumb things in parallel to solve your issues, where you have multiple flows parallel plumbed, evenly spaced apart to produce a larger flow. Please note the trunk lines here in and out must be able to handle the full flow of these 3 filters so that you can put as much water into all these filters as you can to get flow out. Realize we want to maximize the flow through this sort of scenario. So where could I see this being needed? In a large home with Flow Plus cartridges where you can do up to 10 gallons per minute per cartridge, and you could get 30 gallons a minute through 3 of them plumbed on a wall this way. Now, if you needed sediment filtration in front of that, you could plumb series in front of parallel flows. So I could put a large dirt holding filter, pre-filter in front of a parallel flow and get both capabilities out of it. Or in series flow, I can design sediment, activated carbon, and a tighter activated carbon or a different activated carbon to deal with a different issue. So this is going to be more of a treatment train idea, very similar to a backwashing carbon filter and a water softener in a basement. This same sort of process can be applied to drop-in style cartridges. Well, that's a lot of applications that drop-in filters are applied to on a routine basis. You have over 40 of them here, lots of different ways to hunt up business for drop-in style cartridges. I've even seen drop-in cartridges on concrete saws on road construction crew. Saw a 5-inch Big Blue housing on a concrete saw the other day, cutting lines in the street. That was pretty cool. So surface filtration. Everything loads on the outside of the filter. Nothing penetrates into the body. This is important in understanding how the life of a filter in a dirt load situation. This will create a tighter filtration surface long term, but it's going to resist flow. Okay. If you have the pressure to overcome it, surface filters might be fine. Now, depth filtrations, particles are actually brought into the material and trapped inside of it, allowing particle migration and reloading and longer life and greater dirt holding. You will also see these stratify with the different levels of particulate in them as well as we get going towards the core. The nice thing about a depth filter from Pentek is we typically have a core to those filters that give us our nominal rating, not the bulk material on the outside, if you're wondering how that happens. We will wrap it around a core that gives us our final rating and allows us to dirt load very, very efficient. Now, a review of carbon filters that we have available in the marketplace. Carbon blocks. Carbon blocks are basically GAC that is put into a press, like that Play-Doh press you had as a kid. You pressed out and squoze out a tube of Play-Doh. Same thing's happening here, except we're doing it under high temperature with a press, pushing out a tube of carbon with binders that cures, and we cut these to length to meet need. So very, very dense carbon, great at chemical and taste and odor reduction. Most of the time, these are done in 5 micron because they're a surface filter, quite often paired with sediment and pre-filtration in front of it because of this. Great taste and odor removal characteristics. Then you have the Fiberdyne block, which is a wet molded slurry of cellulose fibers and activated carbon molded around a core. And this is a proprietary technology to Pentek. This offers great dirt holding, great contact time with the activated carbon, and great flow rates compared to a carbon block. Quite often better and much better dirt holding characteristics. The first product we're going to look at is our Chlor Plus line. Now, Chlor Plus is an interesting cartridge because this is not the same technology in these filters. These are both radial flow carbon filters, but the Chlor Plus series is a GAC filter with a wrapper, with a 25 micron wrapper around it, so that we're just getting good taste and odor removal of the chloramine in the situation. Now, the Chlor Plus filter, this is a 1 micron rated Fiberdyne block. Much better dirt holding capability here, but both have superior taste and odor reduction here. This is not a cyst rated block though for the Chlor Plus, but it's going to do a bulk of your removal on this. So if we're thinking about getting value for the dollar here, this is where Fiberdyne comes in versus Chlor Plus. So the next cartridge we want to look at is the Diamond Flow cartridge. This is where we're marrying two technologies in one carbon cartridge. It's got a 10 micron carbon core with a 10 micron polyspun outer shell. So you're getting a pre-filter and carbon block in one design. This is just a little more value for the dollar instead of having two housings on the wall. For one, I am a big fan of putting more carbon in a block as possible and having a separate pre-filter. Why? If I'm going to manage dirt, I want to do it with a cheap pre-filter. That's my feelings on it. But here they work synergistically to provide you great water flow and balance. 2,500 gallons, twice the resistance to plugging as a standard carbon filter. You have low pressure drop. You have a 10 micron block and a 20 micron outer wrapper. Very, very loose cartridge when it comes to overall micron size, but great taste and odor and bulk dirt removal in this cartridge. Offered in 10 and 20 inch lengths, 10 micron, superior dirt holding capability, and good taste and odor reduction. Nice balanced filter for municipal waters. Now, when it comes to blocks, Fiberdyne is my favorite product in our drop-in line because of its versatility. If I had to pick one to solve most of my issues other than chloramine, I would be going with a Fiberdyne block. Spend some time doing the math on these for chlorine removal per gallon, and you'll understand why Fiberdyne has so much value compared to traditional blocks. It's an extremely clean product, maximizes holding capacity in it, minimizes pressure drop, ideal for areas with high sediment is a problem, great for well water applications, resistant to premature plugging, post filtration layer, traps carbon fine so you don't have, it's basically in this cartridge, you run water through it for 30 seconds, flush it out, and you're ready to go. Minimize binder blinding. There's no pore clogging with this because there are no binders. We can make custom products with this with batch processes. We have this because that wet slurry mold. We can add lead removal. We can add phosphate. We can do lots of things with this technology to wrap around the block, around that core and make a block. We do sell this technology to our competitors, but we don't sell them the best stuff. So the Pentek block that you're going to get is going to be the best version of this product. There really is no tooling necessary to do this, and we're able to do this very, very well with ultra clean products. So very, very low. You're able to use a very high quality blended carbon in here as well because it ends up essentially functioning as GAC from an extraction standpoint. So we save the best blocks for you if that makes any sense. So fantastic technology, my favorite one. So it's a modified molded block or a carbon fiber block. We use a unique wet molded technology. These are all manufactured in Dover, Delaware. At our facility there, extremely clean product due to the water-based process, maximizes dirt holding while minimizing pressure drop. Many applications require a higher flow rate. This way you can get it. So this is what that material looks like up close without the carbon impregnated in it. But you can see we have all these different paths through this material, holds a lot more dirt of all different sizes, and it reorganizes when it pulses on and off. But this tortured path the water has to basically climb over this material, and it's forced to have more contact with the carbon than it would through a similar density pure carbon block. It's kind of hard to imagine that you get more time. It's about taking residential streets versus the highway is really what you have going on here. Lots of turns, lots of rights and lefts going through here, making sure we're hitting that carbon. So this is the result of a standard block on flushing within the first minute and the minute afterwards. Very, very little particle migration, and this is just because of shipping. The wet molded block versus an extruded block, the amount of dirt, we get double the life or triple the life out of a 10 micron block. We get more than double the life out of a half micron block from dirt loading alone. Nothing to do with chemical extraction. Size of the blocks, we have 1.5 inch up to 4.5 inch. So standard in big blue, 5, 10, 20, and 30 inch cartridges, up to 40 inch. We do make some batch products for certain industries in the 40 inch variety. We can incorporate other active materials up to 60% of the block. So we can do a lot of cool custom formulations with this. And active material must be able to withstand 300 degrees due to curing operation. Custom filters must be made from 50-inch master lengths. Otherwise, the scrap will be created to increase the price of the finished product. So we've got a lot of particulars around this, but we do some customization of that as well. And this, like I said, is my favorite package right here is the CFBC series. These come in 10 and 20 inches, half micron rated, high dirt loading. And this can go 5 to 10 GPM in a single big blue block. That's fantastic. One filter, away you go. I was using this cartridge in my home before I came to Pentek. So that's how much I believe in that product. Used it in my home for years. But the CFB Plus, you have 5 and 10 micron versions of this, up to 30-inch length for commercial applications. You have big blue applications here as well. That high dirt holding capability is really what it's all about. You have specific industries that require, this has AGON additive to inhibit microbiological growth inside the cartridge. Lots of variation here. Flow Plus, this is our half micron cartridges, very, very high flow rates, certified to ANSI and NSF 53. Literally my favorite product in our account. And we don't sell enough of this, to be honest with you. When you start crunching the numbers on dollars per gallon for a change out, I could change a 10-inch Fiberdyne Plus once a year with a family of 7. And that was well within its normal life. That was just from dirt loading. It would slow down enough. Chlor Plus, superior chloramine and chlorine reduction. So if you're dealing with high chlorine situations, you may want to consider this product. Or chloramine, unique designed with the cores to prevent particulate from coming out of them. We're thinking about every aspect. Cheap blocks don't do that, where you get a lot of fines out, you do a lot of flushing. You have 2 choices here, GAC and a Fiberdyne version of that block as well. Very, very good products here for chloramine removal. This gives you higher flow with the removal as well. Now, extruded carbon blocks, we have lots of those. The advantages, they're high capacity. They may be capable of cyst reduction. I don't recommend it because these plug too quickly. If you're going to use a cyst-rated carbon block, you need a pre-filter in front of it. Little or no media migration. Why? We're holding everything together with binders, and can be designed for higher flow rates up to 2 to 5 GPM. Higher cost, but good value. May need sediment and pre-filtration. And 5, 10, 20-inch blocks available in those. The other difference is an extruded molded block, very good at chlorine reduction, very good at VOC reduction, good sediment reduction. The wet molded blocks, Fiberdyne, very good at free chlorine reduction. Cyst reduction is capable with these blocks. Very clean, limited backwashing or flushing. No particle coming out of aerators and taps if you're dropping these in and running. Premium sediment reduction to maximize life of the cartridge. That's critical. Money on a carbon filter if you're plugging it up with dirt. Low pressure drop over the life of the cartridge. It's another benefit here. You're getting good flow throughout the life of the filter, not just waiting for it to plug. And this is what we're plugging on a carbon block, standard carbon block. This is the filtration surface. Not a whole lot of area to get into the heart of this block. The water flows through, good activated carbon contact, but not great dirt holding characteristics. So they're formed with binders under pressure, standard shape of a block. They typically radial flow. We have the EPM series, economically priced, high porosity, maximizes utilization of the carbon block. This is a 10 micron, good chlorine rated block if that's what you're concerned with. EP series, high dirt holding tolerances, utilization of the carbon block, 10 micron, greater removal capacity than the EPM series. This is nominal 5 micron, better than our 10 micron competitors, often used as RO pretreatment. Now, GAC cartridges, there's two kinds. There's axial flow and radial flow. If you see a design like this, this is axial flow. The water's flowing down the cartridge and out the bottom. This is great. It has greater capacity than paper impregnated cellulose cartridges, tolerant of high sediment waters. Why? They're loose filters. This is a good general drinking water taste and odor improvement filter. Low flow rates with these cartridges and may have media migration issues with particulate coming off of them. These are typically coal-based carbon. So this is really solely about taste and odor control with GAC, unless you have a wrapper on it. They're made from large chunks of carbon, and it's just packed by pressure inside a carbon to form a surface. And it's the overall column, just like a backwashing carbon filter that gives you the micron. But strong for strong TO, taste and odor issues, or organic removal. This would make a great filter in a series removal if you were dealing with lots of tannins or organics in the water. I put a GAC filter, and then I would stage it down from there. Advantages of carbon impregnated paper filters: low cost. They can be used as a combination carbonate and sediment filters, but they're low cost. They're going to plug relatively quickly and have short lives. Little or no particle migration. Disadvantage is low capacity. Cellulose-based cartridges are subject to bacterial attack and may plug quickly in areas of high sediments. This is your low cost filter to throw in for free, essentially. Carbon impregnated filters like the C1 can either be rolled or pleated like the NCP to form cartridges. The C1, this is a rolled tube of paper, and the NCP is pleated. Different characteristics, different surface areas, different masses and weights, different filtration characteristics. The C series, economically priced, provides sediment filtration as well as taste and odor, higher dirt loading capacity because of the paper construction, available in 4 sizes and 2 micron ratings, 5 and 10. NCP, this is non-cellulose pleated cartridges, 10 micron rating filter, nominal 10 micron. Okay to use on a chlorinated source. GAC standard filters, superior taste and odor control. If you're having strong taste and odor issues, this is the type of product you want to go through. You may have to back that up or use this in series to get rid of dirt and debris after it. Coconut carbon cartridges, if you're dealing with volatile organics or someone concerned about pesticides and those sorts of things, these are the sorts of filters you want to use. Lower flow, post-filter, reduced carbon fines, variety and available sizes and flow rates. But this is superior carbon for VOC removal. CGAC, this is for chloramine reduction. This is catalytic carbon that's used just strictly for chloramine removal. This is a drinking water sort of filter, low volume, low flow rate. The SGAC, this is silver impregnated media that has Aegeon in it to provide bacteriostatic protection in low flow, low volume drinking water applications, designed for maximum absorption of organics from the water. TSGAC, this has phosphate in it. This is really designed as a pre-treatment for like a hot water device, coffee filters, ice makers, dehumidifiers that will help control scale buildup in small appliances. So small drinking water ice makers, hot water heaters, hot water dispensers under sink, that sort of thing is what this is used for. Actually, good place for this also might be in an RV. Radial flow carbon, this is where the flow comes in from the side. You're going to get better flow characteristics in this design of radial flow GACUs. These are designed for more point of entry applications for taste and odor issues, available in a wide variety of sizes. Cartridges, CBC, taste and odor and chlorine, reduces VOCs from drinking water, and it's cyst rated for crypto and giardia, half micron rating, high chlorine capacity reduction. I would use a pre-filter in front of these as well because of that half micron. You may plug this too soon. Coconut BC cartridges. This is 1,200 gallons of VOC reduction at just over a half gallon per minute over our standard CBC filter, half micron rated, great for taste and odor or organic removal. Another filter you want to use pre-filters to hold up against dirt loading. CBR2 series, highly effective chlorine reduction through more than 3,000 gallons, greater capacity. This is 99.95% reduction of cryptosporidium. This is near absolute rated filtration, but this is available with coal-based or coconut-based carbon in either one, and you do need a 0.6 gallon GPM flow restrictor and a faucet to make sure you get the flow rates out and the contact you need to achieve these results. Another one, pre-filter, I would suggest in front of this. CEP, this is acid wash coconut carbon for low extractables and minimal pH rise. Think about water sensitive, change sensitive sort of applications like hydroponics or dental offices. Excellent for post RO polishing after the fact, depending on the application or the customer's concern. So as we ran through all of those filters in just about 50 minutes, if you have any requests on those, feel free to drop us a line at training.request@pentair.com. If not, feel free to go ahead and ask questions now. We'll unmute you, and we'll go from there. That was a lot of mouthful. Feel free to ask away any questions. But one thing I would suggest you do, if you're selling these in your own business or your own customers, spend a little time doing cost evaluations of price per gallon per application for chlorine removal. You'll find out real quickly that the Fiberdyne product is our best value, even though they're more expensive cartridges. Really, really high value product. So thank you very much for attending. If there's any questions, feel free to ask now. If not, have a wonderful rest of your day.